All right, I wanted to next talk about long division and bring up another term. We talked about dividend, divisor, quotient. I wanted to bring up another term too. So we know we can divide this way, right? We can write division in terms of a fraction. We can write division this way, kind of in a straight inline division. We can also write division this way, right, with long division. And sometimes you might be used to seeing this symbol, right? So the kind of the more curvy symbol, and you'll see, especially in the next, and we might get to one in this lesson, but in the next example, or in the example after next, you'll see we'll have a binomial here, and so that's why I put the bar underneath, is just so then you can tell exactly what you're dividing by, what your divisor is, right? Whereas if you put like this, then you can't exactly tell. Okay, well, if I want to divide by x minus 2, am I just dividing by the negative 2, or am I dividing by the whole thing, right? So when you put this bar underneath, it kind of shows you entirely what you're dividing by. All right, so let's go back and remember how to do long division, right? It's probably been a while, although I know sometimes when we show our work, we do long division. So anyway, so what I would do is I'd say, okay, well, how many times does this 5, the divisor, go into the first number there, right? So 5 goes into 8 one time, right? And then we multiply. In our head, we do 1 times 5, right? 1 by 5, and we get 5. And so then we subtract. 8 minus 5 is 3. Okay, and then we bring down the next number, which is 4. Right, so then we say, okay, well, how many times does 5 go into 34? And we realize that it goes in 6 times, right? So then we multiply 6 by 5, right? And we get 30. Then we subtract again. 34 minus 30 is 4, right? And then we bring down the 7. And then we do the same thing over again, right? We say, okay, well, how many times does 5 go into 47, right? And it goes in 9 times. So we put a 9 on top. And then we multiply 9 by 5, and we get 45. Okay? And then finally we subtract again. 7 minus 5 is 2, right? And we could do decimal and keep on going, right? But I wanted to talk to you about, or just kind of reintroduce, remember the word remainder, right? So when we finish subtracting, we run out of numbers here, right? Then we have a remainder. All right, and so we have our dividend, right? Our divisor, our quotient, and now we have our remainder. Okay, now there's a few different ways we could express this, right? We could say our answer is 169 remainder 2, right? Sometimes we do it that way, right? Back in elementary school or middle school, sometimes we write it like that. But we can also express as a fraction, right? We can say 169 and 2/5, right? So that's another way that we can express our answer. And that's a lot of times how we'll express it in this class with polynomials, okay? So you put the remainder on top, right? And then you put the divisor on the bottom. Okay, and then of course this is the quotient. Oops. All right. So in this problem, or these problems, we're asked to find or write the expression in the form of quotient plus remainder over divisor, right? Okay, so number 50. So we could do this a few different ways. So I could break this up and say, okay, it's a over a, right? Distribute minus 5 over a, right? So I'm just distributing the divisor to each of the terms in the numerator or the dividend. And so a divided by a is 1, right? These just cancel out to 1. And remember, a lot of times the ones are invisible, But here we don't have anything else, so we need to put the 1. Okay. All right, and then minus 5 over a. So really we can see that 5 is our remainder, or negative 5. And so we just put minus 5 over a, and we just leave that. We can't simplify that, so we just leave it as it is. Okay, so that's how we can express our answer. Now we could also do this with long division. We could say, okay, a into a minus 5, so we could do a divided by a, right? How many times does a go into a? It goes in once, right? And then we multiply 1 by a, and we get a. And then we could subtract, right? A minus a is 0. So then we bring down the next term, negative 5. Right? How many times does a go into negative 5? It goes in 0 times, right? So we could put plus 0 here, minus 0. And then 0 times a is 0. Okay, so we end up with negative 5 as our remainder. Okay, so then our quotient 1 plus 0 is just 1 when we write our answer. Okay, and then we put our remainder plus negative 5. So I'm going to put plus and negative is a minus. So I'm going to put minus 5 over our divisor, which is a. Right, so I could write it that. I could work it out long division as well. Right, now this seems a little more straightforward in this situation, but I just wanted to show you long division because we'll need that when we divide by binomials. And so you don't have to necessarily do all this work right now, but just to show you that you get the same result, and hopefully it'll make a little more sense with monomials, and then when you get to binomials, it won't be as much of a jump. Okay. All right. So now number 60. So here, once again, I can just break this up, and I can say, okay, it's 2x squared over 2x plus 4 over 2x. Okay, so the 2's cancel out here to 1. And then with the x's, they're like bases, so I can subtract the exponents when I divide. So 2 minus 1 is 1, but that 1, anything to the first power is itself, so that can be invisible. And then here I can reduce, right? 4 divided by 2 is 2, so I'm going to get 2 on top, but that x is still there on the bottom, and I don't have any x to combine it with on top, so the x just stays on the bottom. All right, so that's our final answer. All right, and we could do that long division as well. So, but I won't show you that on this one. We'll just stick to the kind of the more straightforward way.